guide you through the real life example of how we can actually use data to find like meaningful patterns and just analyze it in a meaningful way. And we will have an example of Titanic passengers data, which is quite interesting. And it's great that we get to analyze it because it's quite a big deal, I guess, for some people, and it should be very interesting today. So I will give Artemii the stage now, and he will guide us through it.
Yeah, so first of all, in order to reach better sound and screen quality, so let me off my camera. I hope it is. So could you see the presentation again?
Yes, we can.
Yeah, that's fine. So hello everyone again. My name is Artemii, and today we will discuss how to create, train, test, and evaluate simple machine learning models in Azure ML Studio. So Azure provides quite simple and understandable user interface, and all you need to do is to drag and drop predefined blocks and modify their parameters. So don't worry, you don't need to write any difficult code at this stage. So the first thing machine learning starts with is the data. So for today's workshop, we decided to choose one of the most popular dataset for beginners, which is a Titanic dataset, so you can mention in the beginning. So what you could see on your screen, that here we have many different fields and parameters that are available and was collected for this dataset. For example, it is maybe age, a fare to describe a ticket price, or embarked, which is a port of embarkation, where C is a Cherbourg, Q is a Queenstown, and S is a Southampton. So we also have some basic parameters such as sex and a class of a passenger, which might be first class, second class, or a third class, and two more interesting parameters which describes. So the first one, CBSP, describes the number of siblings or spouses aboard, and second one is a PARCH, which is the number of parents or children aboard. So in here you could also see some general statistics about survival percentage in general, so how many people in percentage were survived in Titanic. Yeah. So what's next? Our task for today is to train a model which will define whether the person survived in the Titanic or not, based on a set of predictors we have described before. So our model gets personal data as an input and returns an output value which indicates did the person survive in the model's opinion. So in other words, the model has to solve a classification problem of identifying a person to one of two classes, so those who survived and those who didn't. So today we will use two popular supervised machine learning algorithms called logistic regression and support vector machines. So the first one is a logistic regression. It is an algorithm that is used in solving classification problems. It is a predictive analysis that describes data and explains the relationship between the variables. So logistic regression is applied to input variables, where the output variables is a discrete value which ranges between 1, which means one class yes, and 0, which represents no or another class. So in other words, it's, as I've said before, it just represents two classes. So for example, you could see on the screen here is an example of boundary green line which divides our points into two classes, so of blue dots and red dots. And here is an approximate example of a logistic regression model when it gets some predefined classifiers or parameters as an input values and gives us some results as two classes. So the next approach is support vector machine. It is a model used for both classification and regression problems we've discussed our last lecture. So it is mostly used to solve classification problems. So the algorithm creates a hyperplane or a line. So in this case, which is a decision boundary, which separates our data into classes. So it uses a kernel trick to find the best line separator or decision boundary that has the same distance from the boundary points of both classes, as you could see here. And it is a clear and more powerful way of learning complex and non-linear functions. So the main difference between these methods are the following: first, support vector machines tries to find the best margin or distance between the line and support vectors that separates the classes, and this reduces the risk of errors on the data, while logistic regression doesn't. So instead, it can have different decision boundaries with different weights that are near the optimal point. Also, support vector machines work well with unstructured and semi-structured data like text or images, while logistic regression works with already identified and independent variables. So support vector machines also is based on geometrical properties of the data, while logistic regression is mostly based on statistical approaches, and the risk of overfitting is less in support vector machines, while logistic regression is vulnerable to overfitting. So, okay, that was some kind of a short introduction, and let's go directly to Azure Machine Learning Studio, to our main tool for today. So I hope you could see my screen with Azure ML Studio right now. Is it so?
Yes, we can.
Yeah, that's perfect. So here I've already created an experiment environment where we can create, trend test, and evaluate our models. So let's do it step by step. So
Artemii, I'm sorry. Just before we dive in, there was a question in the chat. So it was about the model. The question is it always a straight line or could it be a curve?
So yeah, it's quite a good question. Let me go back to our presentation. As you could see in logistic regression, it's usually an S-type curve, which is based on incoming parameters. However, in support vector machine, it's usually creates a straight line or hyperplane, which depends on a number of dimensions we have in our input data. So, for example, maybe if I'm not quite correct answer your questions, maybe Ahsan could help me.
Yeah, you are right. And it will hyperplane will be on parameters, and the lines will be straight line. But in the logistic regression, it is curved line always, and this curved line has a sigmoid function that will trigger, and that has a threshold of 0.5, or it can increase or decrease according to the requirements. That will trigger the classes either in 0 or 1.
Yeah, thank you so much. So does it answer your question in the chat, I guess? Yes, I hope so. So yeah, by the way, if you have any questions, you could either write it in the chat or open your mic and just ask me during this workshop. Yeah, feel free to interrupt me at any point. So yeah, let's go back to our data. So in order to avoid some errors and unnecessary correlations in the results, it is so first thing we have to do with our data is to prepare it. So here, as I've mentioned before, we have a Titanic data set. We could visualize it in this environment and see what kind of, so it represents as a table, and we could see what kind of columns that describe the personal data we have here. So as I've mentioned, it is also survival, the label which represents that did the person survived or not, personal class, name, sex, age, and others. So first we have to select available columns or identify a predictors for our model. So it goes without saying that, for example, name, ticket description, or cabin, and such as unique ID of person in our table doesn't make much sense for our model. This we must select only the columns that are valuable for our model. So let's find an appropriate block here which allows to select columns in our data set. Yeah, just connect these blocks and run launch column selector. So we select here class also, yeah, sex, age, SIB, SP, parch, as well as fare and embark. So in total we have 8 columns selected in the moment. And as I've mentioned before, so passenger ID is just a unique ID. Name also doesn't really matter for our model, as well as ticket description and cabin description. So yeah, let's do it this way. We could also run our experiment at each step and see step-by-step results here. So we could visualize it and see that we have just exactly that 8 columns that we've chosen before. Okay, so the next step is make some, so as we could see in our data, we have some qualitative columns, for example, as a sex, and as we have some qualitative columns in data, we must categorize it, because machine learning model deals with numbers using some mathematical approaches under the hood. So categorization allows to connect or link each unique qualitative value that exists here with appropriate numbers. So we don't have to do all the things manually, because most of this approaches is already exist in this system. So we just have to find a correct block which calls edit metadata. So connect them. Then choose the column we have to make categorical, which is, in our case, it is sex, as we could see in our data. Also, it is embarked. P class to make it categorical, and survive rate in final. Yeah, I guess it is. Okay. So here we make it categorical. That is our changes for the data, which allows our model to better understand our data. So what's next? I guess we have to label the target values for our model. So we have to identify the target column for model in order to distinguish input predictors from output values. So let's also add the same block called edit metadata. Yeah. Let's pick our target, because survival column represents the a result of survival. So did this specific person survived or not? And we mark it as a label. Yeah, could run this again. So if we look at our data, we won't see any significant differences here, but our data will be labeled and categorized, as we've mentioned before. So yeah, the next thing we have to take into account is to clean a missing data if we have so. So we could again just look at our data, and if we go to an H column here, Azure Machine Learning Studio provides us some general statistics data about our data set, and it tells us that we have 177 missing values from around 900 rows, which is quite a lot, and we have to do something with this value in order to make our model work better. So let's add specific block which allows to clean missing data, connect this, choose the column we need. I guess, yeah, it is the right block. We don't have to choose all the columns. Back and use only H column. Okay, and then we could choose how we change this value. So the most effective way is to replace with the mean or median value. We could completely remove the entire row with missing data, but it is much better to, so especially in our case, to replace it with the mean or median and see the result. So for example, let it be median. Okay. So as I said, Azure Studio provides many different options, but we achieve the best results if we replace missing values with mean or median, and we could then check this by changing only one parameter, and then look at the results of our model. So, yep, let's save it. So the last thing we have to do with our data in terms of preparation is to split our data set. So commonly we split a data set in 70-30 proportion. So it is a standard separation for machine learning task where 70% of our data will be used for model training and other 30% for model testing. So let's add a specific split data block here. Yes, I hope it allows me to, yeah, let it zoom a bit. Okay. And choose the fraction 1.7. So where 0.7 is a fraction of rows in the first output data. So as you can see, there are two outputs, and the first output will contains a randomized split of 70% of our data, and second one of other 30% of the data. So I guess now the data is ready for models training and testing, and so let's create exactly our models. So first thing we have to add is exactly a model. So let's add to train model blocks. So yeah, yes it is. Now for some reasons, yeah, let me update this page. Some trouble sometimes exist with this environment. It is okay. So yeah, our train model block has two inputs, which is exactly a model in a data set. So as I've mentioned before, let's add exactly the second train model. Yep, and connect our data set for training with our model. So yeah, make it like this. So the next point, we have exactly add our algorithm, which is a logistic plus logistic regression and support vector machine. It is. So we won't dive deep a lot into the parameters of this machine. Let's work with, so just for the beginning, let's work with the standard parameters, which are quite well for our small data set, and in general they've already prepared quite right, so we don't need to have any specific modification either. We work with any really specific data, and so if we change something here in parameters, we should definitely understand what we do and for what purposes. So yes, now we add our models, our algorithms, and what we have to do then is to add two score model blocks for visualizing and testing the results of our models. First, score model. Yep. Also two blocks. Yeah. And what does, yeah, here we have also two input parameters. One with is a trained model. So let's connect them. Yep. And the second one is a testing data set. So as we split our data before, we know that the second output is a 30% of our data for testing. So we just connect our testing data sets here. So it looks like it shows an error. Okay, it required a value, definitely. So our train model have to understand which value it should based on as the result. We have to note, and we have to specify an outcome value. So we have to choose this column. Okay, it is not available at the moment because we haven't run this block before. Okay, doesn't matter. We could see at our data set, and we know that survived column is exactly what we need here. So we could just copy it and paste in our model description. Yeah, column selector. Let's make it binary. Oh yeah, it already helps us. Fine. So yes, specify this column for both models and try to run this approach. Yep. So now we have to get our two score models results. So when this block finished, I guess I run only select a block. Let's run all of the experiments. So it has to calculate, all the models. It have to train our models and then score the results. So in order we could visualize our testing results in model, and we could compare actual survival outcome with the predicted results for each of the tested passengers. So for example, yes, this model is ready. We could visualize our data set, and here we could see the actual survived parameters and scored label, which was calculated exactly for specific passengers. So it is not quite, might be not quite convenient to compare it here. So we might use another block about evaluation, which allows us to evaluate our model. So it also has two input values, which is quite nice for us because it also allows us to compare two different models between them. So yep, let's run our evaluate model block and see it in details. So okay, it rerun all the experiment again. Yes, I hope it was created before, and we have to just wait while it evaluate our models. Yeah, it should be done. So let's look at our evaluation results. Yeah, here we can see many different parameters. However, most important and representatives in terms of model quality is accuracy of our model. So of course, the good accuracy level is individual for each specific task, but in general, the accuracy that is higher than 0.8 or 80% can be considered as a quite good accuracy. And so in our case, 0.812 is our first model is a quite good accuracy, and we could look at accuracy of our second model, or it is even better. So it is quite well results that we achieve. So another parameters we could see here, which is also quite important, is the precision and the recall. And precision indicates in what proportion of positive identifiers was actually correct, and recall answers the question what proportion of actual positives was identified correctly. So here in the top, you could see an ROC or ROC curve, which is a receiver operating characteristics. So it is a performance measurement for the classification problems at various threshold settings. So ROC is a probability curve, and area under this curve represents the degree or measure of separability. So it tells how much the model is capable of distinguishing between classes. So as higher the area under curve, the better the model is at as predicting 0 classes as 0 and 1 classes as a 1. So an excellent model has area under curve equal to 1, which means it has a good measure of separability, and it goes like parallel to left y-axis and top x-axis. And a poor model has an area under curve is 0 or near 0, which means it has the worst measurability of separability of our parameters. So here as a gray line, you could see a randomized split, which means that the area under curve is exactly 0.5, and it represents completely randomized answer. So if our model will get us completely randomized answer, so at least we could see here that our model is better than the randomized answer, but it's still worse than ideal model. As we've mentioned before, we have about 80% of accuracy. So next parameters that also used, for example, for calculating this ROC curve and as well as precision and recall is these four parameters which indicate the actual values, which is the actual values, so how our model calculated these values, where it was right. So for example, true positive means a number of correct predicted survivals in our case, and true negative is a number of correct predicted deaths, while the false positive, so we actually get false positive results when person survived, but the model predicted that that it didn't survive, and vice versa, false negative, it is when actually person not survived, but the model predicted that it survived. So yeah, there are many other different results. So we could also see it here. We could see other graphs here, the precision recalls that we've discussed before with the different parameters. Also, we could see a lift line, which is a rate of positive rate and a numbers of true positive results. But we won't spray between them a lot for today. So we've just discussed some main parameters, and we understand that in general, this tool allows us to create a quite good model with 90% of accuracy. And anyway, after this workshop, we provide you a lot of links for materials you can additionally learn to dive deep into machine learning models, results, interpretation, and moreover, we also share exactly this experiment with you, so you can copy it, run by yourself, and explore it in details. So the last thing I'd like to mention that we could also compare the results of our models. For example, we could using this evaluate results block, we could compare our rock curves and other curves together on the same chart, as well as compare all the resultant parameters of our models, which is quite useful when you decided which machine learning approach or algorithm or type of model you wanted to use for your specific task, for your specific data. So you could just work with some testing set in this environment and then implement this in your real solutions. So I guess that's it for today from what I hope it wasn't quite overwhelming for you. I've tried to explain it as much so in most understandable manner. So if you have any questions, you could ask them right now. You could write it down in the chat. You could open your mic and ask them. Yeah, please feel free. Let me go back to our presentation. Yeah, we still have some slides after you ask your questions. So, Evgenia, is there any questions in the chat? So feel free to ask if something was quite, maybe if I understand some points quite fast for you and you wanted for me to repeat some of them and maybe explain some results of our models a bit more in detail.
No, I don't think there are any questions in the chat.
Okay.
So far, but of course, yeah, I think as you mentioned, if you will come up with any questions, you can also reach out to us on social media.
Yeah, of course.
And we'll be happy to answer. And if you also have any proposals on the topics that you might be interested in, or you would like to dive deeper into ML, for example, or explore some specific things about ML, yes, as Artemii shows us, we have a specific survey for that reason, where you can fill out either your own preferences on the topics or check and choose from the options that we provide there. So we would be able to give you more events that interest you. Yeah, but so far, that's it for the session. Artemii, do you want to say any more things or?
Yeah, maybe I could add that I've also might miss this during my description that while you train your models in this Azure ML Studio, you could exactly look at your models and look at the results your model gets for you in terms of weights your model has for each of incoming parameters. So for example, here we could see that the sex is one of the most important parameters for survival in in Titanic in terms of our model decision. And you could also see from other parameters which of them was significant, which were not significant, and so on. So you could at least visualize your results. It's quite helpful if you don't have a lot of predictors or incoming parameters in your data, but if you have around hundreds or thousands of parameters, it is definitely better to evaluate your results in terms of these parameters as accuracy, precision, and recall, and look at your curves you have here and compare it between different models you could run in this environment. Yeah. And again, as Evgenia says, if you have any questions and maybe you want to implement some machine learning solutions and you don't know from which points you could start, you could definitely reach out us throughout our social media, and we will help you to run on to create some machine learning model for your study or just pet projects approaches. Yeah, feel free to connect us.
Yeah, thank you, Artemii. And if there are no more questions or suggestions, I think we can end this session. And it was great to see you guys here, and have a great weekend as well.
Yep. Thank you everyone who joined us today.
Yeah, goodbye, and we'll keep you posted on our next events.
Yeah,
Thank you. Bye-bye.